Hello and welcome to the next section of math in which we're going to be going over finances and Euler's constant. So this one should be a bit of an easier one because it's a lot of calculator work. So for this first question, we need to consider, okay, which will have the highest interest? Well, we need to first think about, okay, let's just suppose we're $1 invested for 1 year, just so that we have a basis of comparison for everything. So you may ask, well, how do I calculate each of these things? Well, I'll tell you. You get out this handy dandy little calculator and you say program and then AcaDec 22. Enter, and then go to interest. And so if it says compounded continuously, this means, look at that, there's an option, continuously compounded. Oh my goodness. And you're going to be solving for the final value because it's saying the highest interest. That means how much are you accumulating on it? So you click enter on that. Initial value, we said that it's going to be $1 because it's just a basis of comparison. So if it ever just says like what's the highest general interest, you could just use 1 as a basis for everything. The rate it gives you 0.046. Make sure you're putting it as a decimal, so moving that decimal place over 2 times to the left instead of at 4.6%. And then we get our time in years, which is going to be 1 year, we said. Remember, we're just doing a basis of comparison. And we already get 1.04707. So let's write that next to this so that we can be ready to compare against the other amounts. So let's go to program, AcaDec 22, and then we get to do some more interest. We do compound interest this time because it says compounded monthly. And then we get final value. Remember, our initial is 1. Our annual rate is 0.047. Our compounds per year, this is monthly, so there are 12 months in a year, so there are 12 compounds per year. And then the time in years is 1. So we can see this is 1.04802. And so we can see immediately that B is higher, so that eliminates A. Then we go to program, AcaDec 22, once again. This is really going to teach you how to do this program. Then we get to do, again, final value, P initial 1, annual rate 0.048, compounds per year. We are doing it this time quarterly, so that means there are 4 times per year, quarter, 4 parts, and then 1 year. We get 1.04887. So we can see that's higher, so that eliminates B. Then we get to the next one where we're going to do interest, compound interest again, final value, initial 1, annual rate 0.049 for this option now. And then 2 compounds per year because we are doing it biannually, bi meaning 2. 2 times per year, 1 year. And we get 1.0496, which means we eliminate C because D is higher. And then we get to compound interest, final value, 0.05. Compounds per year is 1 because it's annually, once a year. Time in years, 1. And we get 1.05. Would you look at that? So E is our option. That is correct. Okay, next up, $95 is placed every week for 20 years in an annuity that earns 5.1 APR. How much is it worth in 20 years? Okay, great. So let's go into the program, AcaDec 22. And as you can see, there's a little option for annuity here because it says annuity. And if it also says you're placing an amount in every certain amount per year, then that's going to be annuity if you keep on placing in. If you have an initial that you place in, and then if you have an initial, then that's going to be compound interest unless you're trying to find the payment amount, which we will go over later. But in this case, it says annuity, so we know it's annuity. But if you see this placed in every week, then you know it's annuity. So we're going to find the final value here. Payment amount we know is $95. We know the rate is 0.051 here. We know the compounds per year is going to be every week, so there's 52 weeks in a year. Time in 20 years. And we get that option C right there. And our calculator just gave it to us, so pretty easy. And then let's go to the next question. So this says APR here. Don't let this get you tripped up. This is still compound interest because it's an initial amount and you aren't putting in new money every single time. So we're just going to go to AcaDec 22. We go to interest, compound, and then we're going to find the difference between these two. So first one is finding the final value for $50,000 initially at a 0.051 APR, compounded annually once. And then how many years? We have 8 years because we're finding it for 8 years for both of them. And so we're going to go ahead and write down this number so we can remember it for later. 37.49207. Okay, so next up, we're going to go back to the program. We're going to go interest, compound interest, final value, still $50,000 because we're putting it in the same account, or not in the same account, we're putting the same amount in each account. 0.049 for this one. Compounds per year is 16, time in years is 8. And then we get 73952.57269. So if we go ahead and subtract those two values on our calculator, which I'm going to do off screen because it's kind of tedious if I'm honest, to put it right in front of the screen while I'm typing in. I can do it much faster this way. So hopefully you're typing into your calculators, and we get 484.9. Would you look at that? 485. That's pretty close. So that's your answer. Because, yeah, if it's this close, yeah, that's your answer. Next up, $60,000 is placed in an account that compounds semi-annually. Guess what we're going to use again? The calculator. Woohoo! And it's worth twice its initial deposit after 8 years. Now, this might be where it trips you up. Your final value, you now know A equals $120,000 because it's twice the initial deposit, so 120. So we're going to go to program, AcaDec 22. We're going to go back to interest and compound interest. But this time, we're actually solving for the interest rate. So annual rate, decimal, you go down to there, click that. You know your final value, 120,000, because it's double the initial. It tells you right there. It's worth twice the amount after 8 years. Then P initial, 60,000. 2, 3. And then compounds per year, semi-annually, that's twice per year. Biannually, semi-annually, same thing. Time in years, 8 years, and we get 8.855%. Yay. Next question. $17,000 is loaned for 6 years at an 8.1 annual % interest rate. If it is repaid monthly, how much must be paid per month? Okay, so this is hard because paid per month, this is annuity, but $17,000 is loaned, a single amount, initial amount, that's compounded. So we have to do both. So in order to figure out how much total must be paid, then we go to program, and we go to AcaDec 22, and then we go to interest, compound interest. We do what we've been doing. Initial at 17,000, rate 0.081. Compounds per year, we have 12 compounds per year because it's repaid monthly. That's the same as compounds, okay? And then 6 years. So we know our final total is going to be 27,593.50553. But the thing is, we need to figure out how much is paid per month. And so we're going to go back into our programs, AcaDec 22, and we're going to go to annuity this time. And so we're going to find the payment amount. And now that we have the final value, we can say, oh, would you look at that? It's 27,593.50553. The annual rate, 0.081. Compounds per year, we have monthly, so 12. Time in years, 6 years. And we get our payment amount of just about $2.99. Okay, next question. We've got $200 invested in 4% compounded quarterly, 6 years. And then after 6 years, it earns 3.6 compounded and instead, compounded monthly instead. And then we have to find the value after 15 years. So this is going to be a bit more complicated, but I'm going to walk you through it. So go program. Once again, AcaDec 22. We're going to go back to interest. We got compound interest this time. And so we're solving for the final value again. But this time we're only going to do the first 6 years first. So we're going to do $200, rate of 0.04. And then we have compounds per year. We're going to be doing quarterly, so 4 compounds per year. Time in years is going to be 6 years because it's after 6 years. And then we get this amount, right? So we're going to write that down real quick. 253.94692997, just so we keep track of it in case we lose it, because if you scroll up on the program, then it'll lose it. Then we go to compound interest again, and this time for our initial, we're going to put in this number right here because that's how much has accrued after 6 years. So 253.94692997, and then the annual rate is going to be now 0.036 because it's 3.6% now. Compounds per year is now monthly instead, so 12. Time in years, well, 15 minus 6 is 9 more years. So we're looking at the total is 15 years, but we've already done 6 years, so it's going to be 9 years. And so our final answer is $350.95. Yippity-doo-dah. Okay, so that's that. Okay, next up is an easier question because you have, once again, your calculator program. So if we go ahead and look at the AcaDec 22 thing again, you go down to interest, and you can solve for almost any variable with these calculator programs. So you just go to interest, or wait, this is annuity. Apologies. So you actually go to annuity because it's placing per month, and then we're going to be solving for time in years. See how it asks how many years? Well, that means you're solving for that many years. So these programs give ability to solve for different types of variables, as we've seen. So the final value we need is 10,000, and then payment amount is $225. Annual rate is 0.053. Compounds per year is 12 because we're putting in per month. And so we get 3.389, which is B. Okay. Now, this next question, it was worded wrong. You actually need the years here. If it says compounded indefinitely, guess what that's going to be? That's right. It's going to be some continuously compounded. And so we're finding the final value here, $2,000, rate 0.01, that's the APR, and then 100 years. And we get 5,437 here. And then we get to this problem, which just looks ugly. But if you know something very key, then this should be easy for you. The sum, k equals 0 to infinity, of 1 over k factorial is equal to, guess what? E, Euler's constant. So have you ever looked at E before? 2.718281828. So yes, this is a very nice constant that you'll be using. So you just have to say, oh, that's equal to E. Guess what else is equal to E? K equals 0 to n. Now, no, this is when the limit of n approaches infinity. So, or when k, wait a minute. One moment. Okay, so this is just a difference of the binomial expansion theorem. Shows that if you keep adding the terms of n choose k, 1 over n to the power of k, if you keep adding these up, then you'll get e. But the problem here is you have to simplify it for it to actually equal a. And so AcaDec here is just kind of being like weird, where this doesn't actually technically equal e. I mean, it kind of does, but it's kind of like this has to be infinity, but that also doesn't work because that'll be 0. But in its essence, it's the way of expressing this, which it's if you take the limit as n approaches infinity, that will equal e. And so they just want you to know that. And so they're just showing you that's binomial. So since we know that this is equal to e and this is equal to, if we were to multiply by 2 and then multiply by 2 here, that would get us exactly what we have like this, like that. And so this is just equal to 2e. And then this is equal to e right here. And so it's 2 times 2e times e, which equals 2e squared. But this is kind of a bad problem because this doesn't, without the limit, it doesn't really happen. So that's not quite accurate, and they wouldn't really test you on that. Just you got to know the formulas that these do work if you have a limit and if you have the infinity there, and if you seem to have a another way of expressing e right here. So that's a more important one, really. Okay, so this next one is much less complicated. We just go to 1, AcaDec 22, interest, or no, not interest, annuity, because annuity. We're looking for how much must be invested in per week, so payment amount. So we know our final value is 6,472, and then we know our annual rate is 0.024, and then we know it's per week, so 52. And then after a single year, 1 year, that'll be 123. So I hope this video is helpful in understanding all the calculator programs for you, and thank you very much for watching.